So let's look at an example where we use a binomial probability distribution. Okay, so here's the scenario. We have, according to flightstats.com, American Airlines flights from Dallas to Chicago are on time 80% of the time. Suppose 15 flights are randomly selected and the number of on-time flights is recorded. First of all, let's explain why this is a binomial experiment. Well, what's the trial here? The trial would be to examine a single flight and to say whether it's on time or not. So there are those two possibilities. Two possibilities, possible outcomes in each trial. Those are on time and not. Let's see, have we fixed the number of trials? Fixed number of trials. How many flights are we going to look at? Let's see, 15. So that's fixed. Let's see, are they independent? So we are randomly selecting these flights, and so I think that they are independent of one another, and that they are the probability that any one of those flights is on time is 80%. That's not changing from one flight to the next. So I think we're good to go in saying that this is a binomial experiment. Find and interpret the probability that exactly 10 flights are on time. So I'm going to use my calculator for this. Let's see. Exactly 10. So this is a PDF problem. So I'm going to go to my distribution. Binomial PDF. Let's see, the first argument, how many flights am I looking at? There are 15. The probability that one is on time is 80%. That should be a comma, 0.8. And in this case, I'm looking for the probability that exactly 10 are on time. So the notation I would use here is the probability that x equals 10. That's exactly 10 of the 15 are on time. And that probability is 0.103. So there's a little more than a 10% chance. Find and interpret the probability that fewer than 10 flights are on time. So fewer than 10, the probability that x is less than 10. This is the same thing as saying the probability that x is less than or equal to 9. And so that is a cumulative probability for up to 9. And so I'll go to my distribution menu, and this time I'm going to choose the CDF. There are 15 trials, probability of 0.8 of success, and I want to say up to 9. And so this is 0.061. So about a 6% chance. All right, find and interpret the probability that at least 10. So the probability that x is greater than or equal to, at least includes 10. And so the thing to realize is, I'm off to the side here, think about what this entire probability distribution would look like. I have 15 flights. So my probability distribution would go all the way from 0 to 15. Now, in this example, find and interpret the probability that fewer than 10, so that was, in that question, I was looking at this. That's fewer than 10. And now I'm saying at least 10. So at least 10 would be 10 or more. That's this. Now notice that those two groupings together make up my entire list of possibilities with no overlap. So those are complements of one another. So I can say that the probability that x is greater than or equal to 10 is 1 minus the probability that it's less than 10, which is what I found in the previous question. So that's 1 minus 0.061. 1 minus 0.061. That's 0.939. And now what about between 8 and 10, inclusive? So between 8 and 10 inclusive. Now I could add up these three probabilities, but I am going to be fancy and find the entire group from 0 all the way up to 10, and then I'm going to just subtract off these. So I'm taking, and then I'll just be left with this group. So the way I'll do that is I'll take the CDF, the cumulative probability, up to 10. So use my binomial CDF, 15 trials, 0.8 and 10. And I'm going to subtract the CDF, binomial CDF, for up to 7. There are 15 trials, 0.8, 7. And I'll get, for the probability that X is in between 8 and 10 inclusive, that's 0.15999. If I'm just rounding to 3 decimal places, that'd be 0.160. So about a 16% chance of that happening. All right, in the next question, we are asked to compute the mean and standard deviation. In this case, if 100 flights are randomly selected. Okay, so the mean or expected value for a binomial probability distribution, the mean or expected value is found by taking n times p. So that's the number of trials and the probability of success. Now, in this case, I would be taking, there are 100 flights, and we know that the probability of success is 0.8. So we would expect 80 flights to be on time. So that's 80% of the 100. Now, the standard deviation for a binomial random variable, that's sigma, is a square root of n times p times 1 minus p. So in this case, I'm using 100 times 0.8 times 0.2. That's 1 minus 0.8. And I need to take the square root of that result, and it's 8.955. So the mean is 80, the standard deviation is about 9. So what does this mean? If we take many random samples of 100 and look at the number of on-time flights, and then we average those values, I expect them to average 80. Let's see. So that's the long run mean number of on-time flights in random samples of 100. Okay, would it be unusual to observe 75 on-time flights in a random sample of 100 flights from Dallas to Chicago? Well, let's see what's the probability that you would get exactly 75 flights. So this is a PDF problem, binomial PDF. This time I have 100 trials. The probability of success is 0.8, and I'm interested in 75 successes. And so that has a probability of 0.044. Now, something to be aware of. Pay attention when you're answering questions like this. Would it be unusual to observe 75? This indicates that it observed exactly 75, But we could have also said 75 or more, in which case we would have to find, that could be 75, 76, 77, all the way up to 100. So in order to say the probability that x is 75 or more, that's a greater than or equal to, it might be easier to say 1 minus the probability that x is less than 75. And so that would be 1 minus the probability that x is less than 74. I'm sorry. That's 1 minus. So this probability that x is less than 75. What I meant to say there is 1 minus the probability that x is less than or equal to 74. Okay, and that we can find using our CDF function. So distribution, CDF, we've got 100 trials, a 0.8% chance of success, and I'm going to use 74, and I want to take 1 minus that answer. And so this is 0.913. So be careful here. If you want to know would it be unusual to observe 75, there's just a less than a 5% chance. Yes, that's unusual. But 75 or more, there's a more than a 90% chance of that happening. So that's an important distinction there. All right, I'll work some other examples in another video. So I hope to see you for example number 2.